Hi, Sophia. Let's see if Lucas is here or not. Zoom in on here. Alright, so the first thing that I wanted to kind of do was go over the tentative schedule for the rest of the year. I don't know if you've been watching the news or anything, but Trump declared until April 30th that we're all in a stay-in-place thing. So I'm assuming that the governor will probably at some point follow suit. Okay, so what is today? The 30th, I think? Yeah, so today's the 30th. We're actually not doing too bad. So here's our schedule. And so today's the 30th and we're going to do 10.1 today. Okay. Tomorrow's Tuesday. I think we should go ahead and do 10.2 tomorrow. So that's where I'm looking at so far. Now, I know we still need to do some labs, so I think from Wednesday to Friday, let me double look, but I think you guys are on lab 8. I think you were in the middle of lab 8 the last time we left. Let me look. Yep, because you did lab 7. So you need to finish lab 8. I think there's only 10 labs now. I know I have 12 labs on here. There used to be 12 labs. I'm gonna have to double look. I think they cut it down when they switched teachers down to 10 labs instead of 12. Because what they used to do is they used to drop the lowest 2 lab grades. But now I think they just made it 10 lab grades and you get multiple attempts. So I think that's how they changed it. Alright, so I think that we need to do lab 8 this week. And you guys will have those days to do it. Now, because you have to do it online, I really don't know if they would know if you work together or not. I mean, honestly, I have no idea how they would even know that. The thing is if you work by yourself, then you don't get multiple attempts. You know, like one person submits and then the other 2 fix their answers. So I think you guys are going to need to try to collaborate. If you would like to work on lab 8 together, I think those 3 days would be good to finish lab 8. Alright, and then this is spring break. So we're not going to do anything that week. Alright, I'm going to turn this over. Okay, make sure these overlap here. So it's really kind of irritating. Okay, this was no school. This said SAT no class. Well, guess what? We're not doing that SAT anymore. So I can erase that. And I think we should do 10.3 that day. Alright, so we're going to do 10.3 on the 14th. So that'll be our live. So this is today with 10.1, 10.2. And then we'll go spring break. And Easter Monday, we'll take that off too. So then this week you need to do lab 9. Okay, so that leaves this week as 10.4, 10.5, okay, and then we kind of need to figure out, do we want to do the review on the 22nd for the final, or do you want to do that this week and that gives you time to do lab 10? And then we can do our review on the 27th, and then these other days you can figure out what day you want to do your final. What do you guys think? Give me some guidance of what you want to do. If you want to do the review on the 22nd and then you're kind of on your own to do your lab and then your final and you just want to get it done and over with. The justice says we're coming back on this day, but I don't think that'll be accurate. With Trump saying on the 30th that everything's closed, I would think that would be the first day. But I figure we might as well just get it all done and over with. So do you guys have any opinions on when you want to take your final? We can think about it later too. You guys are awfully quiet. Okay, here we go. I'm fine with the 22nd, whatever works for everyone else. I don't really have a preference. Okay, so we can probably plan to do the review this day for the final. And then that would leave you with lab 10. We'll just make this tentative, and if we want to change it, we can. Lucas isn't online, so I don't know what Lucas's preference would be. So then you'd have to do lab 10, and then I would say the final. And the final's two different sections, but I think you could just do them all in one shebang if you want. So final number 1 and final number 2. He had broken it down into 2 smaller sections since our classes were only like 50 minutes. So it was easier for us to just do the first part one day and then the second part the other day. That's why there's 2 sections. If you were doing this on campus at WVU, it would just be one big final, one big long final. It wouldn't be broken into 2 parts. All right, I think this is pretty good tentatively for the rest of the month and to get us through everything. Then I would probably say tentatively, I think we can make your homework be due on the 30th for that last homework. So homework, that last section. That should give me enough time to grade it and then give WVU their thing also. Their grade, because I have to submit that grade to WVU. Alright, so that should be good with our schedule. Alright, let's get started. This is 10.1. This is polar coordinates. Now, most of the final is everything on the new stuff, not the old stuff. All right, so we have polar coordinates. And this is in the format r comma theta, where r can be in degrees or r can be in radians. It doesn't really matter. So if you look at an angle on here, here is your theta. Here would be the radius, so that's your r. So your point P is r comma theta. They call this the pole. And then this is your polar axis, the line. And your r can be either positive or negative. If it's positive, you go this ways. If it's negative, you just start down. All right, so I'm going to kind of show you with the graph paper that you should have, the circle graph paper. what it looks like. And then I'm also going to just do it on notebook paper too. You're really going to want to save the graph paper more for 10.2 because that has all the fancy drawings and stuff. Alright, so this is for sections, I think 11 through, let me see what it would be. I think 11 through 30. And to your homework. So the first one we're going to do is plot 2 comma pi over 4. Alright, so the first thing we're going to look at is our graph paper. Well, the problem is I don't know if I gave you the one in degrees or if I gave you the one with radians. I really can't remember. So can you give me a shout in the comments? Did I give you this paper? Or did I give you this one? Because I had 2 different ones, and I don't remember which one I printed off for you guys. So did I give you the degrees or the radian paper? It's in radians. Okay. Alright, so we're going to use the one with the radians then. Okay, so pi over 4 is this one here, and each line would count as 1. So this is a 1, and this would be 2. So right here is 2 comma pi over 4. Now if you were going to graph that on notebook paper, which you might want to just do the homework on notebook paper, I just eyeball the pi over 4, and then you can put like a tick mark, 1, 2, and then put your dot there, and that would be your 2 comma pi over 4. Alright, I'm going to keep using this same plotting paper that I had before. The next one we're going to plot is -3, 2 pi over 3. Alright, so the first thing you want to do is find your 2 pi over 3. And since the radius is negative, and this is where it gets really cross-eyed, and you're probably going to be best to do this with a ruler. So here's your 2 pi over 3. These are the positives. The opposite side of the line would be your negatives. So I would get a ruler so you don't do this all cross-eyed. So get you some kind of ruler, find the line that's your 2 pi over 3 line. So there's the line. Straight edge really helps. And you're just going to go 3 down. So that would be 1, 2, 3 down. So if it's negative, you just go downwards. So that's -3, 2 pi over 3. Alright, so I'm going to graph this over here. So here's your 2 pi over 3. And then this would be your 1, your 2, and then here's your 3. Okay, so the last one for that section, and this should give you a pretty good overall of all of these. 2 comma negative pi over 4. Okay, so if I come back to the paper, regular pi over 4 is here, but you want to go down to pi over 4. So that would be here. And then since I want 2, you're just going to come out 2 dots. So 1, 2. And the larger paper definitely helps with this. Alright, so that is 2 comma negative pi over 4. And I do believe that plotting or being able to read off of the polar coordinate thing was on the final. So we have down here, and then this would be 1, And then your 2. And of course, downwards was your negative pi over 4. Okay, so this next one is going to help you out with number 32. I think I'm going to actually do 32 on here, but this would be for 31 to 38. Okay, so there's this little definition. It basically says if you have a polar coordinate, then you can be represented by 2 different things. So this is just a definition. So a point with polar coordinates r comma theta can be represented by and the first one would be r comma theta plus 2 pi k, or you could have negative r comma theta plus pi plus 2 pi k. And that's just a definition on page 726. Okay, number 32 says plot each point given in polar coordinates and find the other polar coordinates of the point which represents, and then they give you an A, a B, and a C, I think. Okay, so here's the point they give you for 32, 4 comma 3 pi over 4. All right, and the first thing they want you to do is to plot it. So I know that this here has to be 4 pi over 4. So for 3 pi over 4, I know it has to be the one here in the middle. And then you would have 1, 2, 3, and 4. So basically what parts A through C is actually asking you is they want you to give different names for this exact same point by saying, okay, you could use the negative, but they'll give you the situations, or they could say you could do a revolution around, but they want you to just give different names for them. Okay, so the first one, r is greater than 0, and we're between negative 2 pi. I should have a line like that. Okay, so we're between negative 2 pi and 0. Okay, so basically what you want to do is you want to take this coordinate here, the 3 pi over 4, and we're just going to subtract off a 2 pi from it. So we're going to take 3 pi over 4 minus a 2 pi. So whenever I do that, that's going to give me negative 5 pi over 4. So my answer, because they want r to be positive, so the only way that I could keep r being positive here and to be in the right thing is now I have 4 comma negative 5 pi over 4. Okay, so basically what I did was I started here and I went over this way. So that gives me between negative 2 pi and 0. Okay, part B, now they want r to be less than 0. So we're going to be looking at this part right here where r is negative. We're going to be between 0 and 2 pi. All right, so since we want r to be negative on here, what I want to do is start with r's going to be negative 4 since r is negative. So I know this is going to be negative 4 comma something. So to figure out that something, we're going to use this. The theta plus pi plus a 2 pi plus some k that we'll have to figure out what that is. Okay. So I know that what I'm looking for is going to be down here in this quadrant. So all I really need to do is take 3 pi over 4 and add a pi to it. So this would be 4 pi over 4. So if I add those together, that's going to give me 7 pi over 4. Which that would be over here, but then because this is negative, I'd plot it over here. So that would be your answer there. Now I didn't want to add on the extra 2 pi k on here because I didn't want it to be higher than 2 pi. 2 pi was the maximum I want it to be. So you didn't want to add in the extra. I didn't need that extra revolution. Okay, question C. R is greater than 0. We're between 2 pi. We want to be less than 2 pi. And 4 pi is going to be the max. Okay, so basically what I want to do is I want to keep r being positive, but I just want to add on an extra revolution on there. So we're going to keep the 4's being positive, and what we're going to do is we're going to take our 3 pi over 4, and we're going to add on a 2 pi to it. So that will take me around one more time. So this would be 8 pi over 4, so 3 plus 8 would give me 11 pi over 4. And that would be your answer. Alright, so do we need another example like this, or were we okay with this? So give me some kind of comments down below. Okay, so alright, we'll stop there then. That's good with you guys. Alright, we're going to go with converting from polar to rectangular, and then I think we go the other way around at the end. This is definitely on the final for sure, being able to convert from polar to rectangular and vice versa. Okay, so to convert from polar to rectangular, we basically have a big definition that we start with, and then I'm going to show you where they got the definition from, in case you're like me and you're kind of bad at remembering definitions. Alright, so if P is a point with polar coordinates r, theta, polar coordinates r comma theta. The rectangular coordinates would be an x comma y. That's a lie. Are given by x equals r cos of theta and y equals r sine of theta. Okay, so here's where that's coming from. If we have a graph and we have an angle off of there, this is the angle of theta, and this coming down would be the y, and this over here would be your x, and this from here to here would be the r. So if I had theta over here, cos of theta would be x over r. And then of course you would times by r on both sides. So you get r cos of theta equals x. And then if you wanted to get y, I have the opposite in the hypotenuse. So that would have to be sine. So sine of theta is y over r, and then again times both sides by r, and that's where we get the r sine theta equals y. So you don't technically have to remember these because you can derive them from coordinate grid, which I usually most of the time have to end up doing that because I forget. Okay, so this is find the rectangular coordinates of the points. Wait, here we go. Okay, so we're going to do 6 comma pi over 6. This should be, let me see, find the rectangular coordinates with the given polar coordinates. Okay, so this should be for 39 to 54. Well, 54. So this is 6 comma pi over 6. So your 6 is your r, and your pi over 6 is your theta. So what we're looking at is our definition, x equals r cos of theta. So you're just going to plug in what you already know. So x equals your r is 6, and your cos of theta is pi over 6. Okay, so then you would want to draw that triangle out. So pi over 6 would be 30 degrees. So hopefully you remember what has to be diagonal from the 30. It has to be the 1, that has to be the square root 3, and that has to be the 2. So if I come over here, this is going to be 6. Cos of this would be square root 3 over 2. Okay, so basically this is saying what's half of 6. Well, half of 6 would be 3. So this is 3 square root of 3. That's going to be your x. And then we'll do the exact same thing with the y. So y equals r sine of theta. And again, we're going to plug in what we know from the definition. So y equals 6 sine pi over 6. So if I look at this one, sine would be 1 over 2. So this is 6 times 1/2, and half of 6 would be 3. And then you just put this in coordinate form, so x comes first. So your answer would be 3 square root 3, comma, 3. And that would be your answer for that one. Okay, and then they want us to go the opposite side. Okay, so this would be for 55 to 66. Okay, so now they're going to give you the rectangular coordinates, and they want you to convert it using the polar coordinates, okay? So we're going to convert from rectangular coordinates to polar coordinates. All right, and our coordinate is going to be 2, -2. All right, so the first thing I'm going to do is I'm going to graph this for you. So we have 2 and then -2. So that would be down there. All right, so we need to figure out an r, which would be our radius, and then we need to figure out a theta. So the first thing that you want to do is we need to find the radius. So we need to find the length of the line right there. So we're going to use the distance formula. So we're going to find r using the distance formula, except we're going to use 2, 2, and then our other coordinate is going to be right there, 0, 0. Okay, so I'll put a note on there that you need to use the distance formula so you don't forget. So your radius, and you can in future problems use this shortcut because this one coordinate's always going to be 0, 0. So if you want to shorten it, it's x squared plus y squared. Since when you subtract your 0 off, it doesn't really matter. Okay. All right, so this is going to be 2 squared plus -2 squared. So 2 squared would be 4. This -2 squared would also be 4. So our radius is going to be the square root of 8. And the square root of 8 will reduce down to 2 square root 2. All right, now you're going to want to use a trig function, and I always pick the same one because if you use the tan, it has the x and the y already given in it. Where if you use the sine and the cos, then they have the r. And I would rather use two numbers that don't have a square root. So my personal preference is I always use the tan function to find theta. So tan of theta is y over x. All right, so when we want to find theta by itself, what you're really going to do is the inverse. So, and you can just do this all the time just starting out. So theta is really going to be the tan inverse of y over x. Okay. So that's going to be the tan inverse. Our y is going to be -2. And 2 is going to be our x. Okay, and then I would type that into a calculator. Okay, and I believe we're going to need to be in radians since we have everything I think should be in radians for this. So second tan, -2 divided by 2. Yeah, maybe I was wrong. Yeah, maybe we want to be in degrees, because that's not the right answer. Let's try it again in degrees. Second tan, -2 divided by 2. Yep, that's the one we want. All right, so you want to be in degrees when you're doing this. So this is equal to -45 degrees. I just think that that's way easier to think of in my head than it was that decimal in there. I think it would have taken me a while to figure that out. Okay, so -45 degrees would be that, which would also be -pi/4. All right, so then our answer, so our radius was 2 square root 2, comma, -pi/4. All right, now this could also be multiple other answers, okay, because that is that point there. Now, it could have been the opposite of the one over here. Okay, this is the answer I believe the book's probably going to give you in the back of the book, but I do want you to realize that these have multiple answers. It just depends on, okay, what if I add a revolution to that? Okay. Or if I think of the positive of it, instead of going negative, if I thought of it going this way, I could also get 2 square root 2, comma, 7pi/4. Instead of coming down if I went counterclockwise instead of going clockwise. Okay, and I also, or it could also be -2 square root 2, and then you could have 3pi/4, because that would be the other connecting part over here. I believe this is the one that the book's going to give you, but I do want you to be aware that there are multiple answers to these. I'll have to look at the final to see if this is one of those check all that it could be, but it's possible. Okay. Okay, so the next one that I have on here is transforming an equation from polar to rectangular form. Let's see where that would be. Write the equation in r, I'm trying to figure out what numbers this would be on your thing. I think this would be 75 to 82. We have to do those, right? Let me double check. Yep. All right, so this would be for 75 to 82. I just had to double check that we had to do that. All right, so this is transforming an equation from polar to rectangular form. Okay, so first one I'm going to give you is r equals 6 cos of theta. All right, now the first thing that you're going to want to do is you're going to want to multiply both sides by r. Okay, so our goal is that we can convert r squared is equal to an x squared plus a y squared. So that's the whole point of why we want to multiply both sides by r. So that's going to be our first step. So we'll times this by r, times this by r. Okay, so over here I'm going to get r squared equals, I'm going to move this r right behind that 6. So this is 6r cos of theta. All right, now you also kind of need to remember what did r cos of theta equal. So this is also another recall. So recall that x equaled r cos of theta, and we won't use this in this problem, but you might in future ones, but also that y equals r sine of theta. We're going to use the one that says this. Okay, so r squared is going to be replaced with x squared plus y squared, and the r cos of theta is going to be replaced by an x. So x squared plus y squared equals 6x. Okay, now we're going to move the 6x to the other side. So we're going to minus the 6x on both sides, and we're going to put it with the x squared coordinate. We're going to put it right in behind there, and we're going to leave some space because we're going to have to complete the square. So x squared minus 6x, leaving some space, plus y squared equals 0 because this 6 minus 6 is 0. Okay, so right here you're going to need to complete the square. And it kind of makes sense that you want your answer to be in a format where you have a circle as your answer, because, you know, these are all circles. Everything we're doing here is a circle. All right, we're going to complete the square. So you look at this number, and it's going to be -6. We divide that by 2 and square it. Add it to the other side. -6 divided by 2, square it. Okay, this and this come together in the one parenthesis set. It's been a while. All right, so -6 divided by 2, that would give you -3. And the square goes on the outside. We just ignore this. The only reason we have that is to get this. Plus y squared equals, okay, so -6 divided by 2 is -3. -3 times -3 is 9. And that's your answer right there. Now, I don't know if they asked you what the center and the radius is. Let me look. Did it ask you that? Equation. I don't know. But if it did ask you that, your center, you change the signs. So that would be 3, 0. And then if it asked for the radius, you would just square root your 9. So that would be 3. I'm not sure if it asked you that or not. You'll have to look at the back of the book and see. All right, I do have one more problem for what you do whenever you have a number in front of the x and it doesn't come out quite as pretty. So this is the last one. 3r equals sine theta. Okay, so step 1 is still the same. You're going to multiply both sides by r. That's not changing. So we have 3r squared equals r sine theta. All right, step 2 is still the same thing. You're going to plug in r squared as x squared plus y. Now this time, since I have the r sine theta, I'm going to plug that in as being a y. So this is going to be 3 times x squared plus y squared equals y. You are going to want to distribute your 3 out. So we're going to do distributive property here. So 3x squared plus 3y squared equals y. And then I would go ahead and move the y to the other side. So we have 3x squared plus 3y squared minus y equals 0. Now when you complete the square, this always has to be a 1. You can't have a 3 in the front, so we have to divide every single piece by 3 to get rid of that front runner. Okay, so I get x squared plus y squared minus, you can write this as a 1/3 y if you want. We'll leave some space to complete the square, equals 0. Okay, so we're going to complete the square here. All right, so I'm going to bring this out to the side, and this is going to be negative 1/3 divided by 2. Okay, I'm going to go ahead and put your 1 underneath the 2. So what we're going to have to do is negative 1/3 times, and we'll need to flip those, 1/2. So that's really going to be negative 1/6. So this is what my brain was thinking. So this is going to be negative 1/6 squared. Okay. All right, so our answer, we got x squared. Well, I didn't really need the parentheses there. Plus, and then we'll put the y's together. Y minus 1/6 squared equals, and then if you want, you might as well just leave that as negative 1/6 squared, because when you go to do your center is going to be 0, 1/6, and then your radius is just going to be not negative 1/6, because you'll have to get rid of the negative, but you square root that, so it's just 1/6, because you can't have a negative radius, it has to be positive, or you wouldn't have a circle. Okay, so that is everything for 10.1. Okay, and we will do 10.2 tomorrow at 12:30. Okay, everybody good? Was there any questions or anything before we get off of here? Okay. I'm just waiting here to see if you guys had any questions or comments or anything before I end the stream. Okay, what's your question? It's okay if it's not about notes, that's fine. Go ahead and type your question. I'll do my best to answer it as best as I know. And then tomorrow is the day that we're really using the polar coordinate graphs. So make sure tomorrow that you have your polar coordinate paper ready when we do tomorrow's notes. Yeah, in the Remind app, don't do it on this chat, but in the Remind app, send me your email address and then I will email that to you. Okay? Yeah, make sure you definitely do a test print to make sure that it works before you print it on the paper itself. Yeah, just send that to me in the Remind app and then I will resend that to you, okay? I'm not sure why it was blurry. But yeah, I'll make it work. I got a really good scanner at home, so I can rescan it and everything and make sure I scan it on the highest quality. Okay, well, I think we can go ahead and end the stream, and I will see you guys tomorrow, okay? Have a good day.